Hello everyone, it's Rocky again. Haven't seen you for a while. In our last video, we introduced the UE8M0 new data format. Its appearance was one of the reasons for the Chinese stock market surge. If you can't remember, you can go back to watch this video. Okay, today we're going to dive deeper. We will understand what exactly is UE8M0 and what exactly is for microscaling technology. In this video, I will help you to understand the future directions for LLM and GPU. First of all, UE8M0 belongs to the OCP microscaling standard. It's an open data format jointly proposed by giants like Microsoft, ARM, AMD, and NVIDIA, etc. Microscaling is defined as sharing one scaling factor across a small block of data. As you can see in this diagram, the X presented the data and the scaling factor compresses high precision numbers into lower precision for storage, then restore them during computation. This greatly reduces bandwidth usage while maintaining accuracy. In the protocol, element data represents the value and scale data type represents the scaling factor. And here, the scaling factor is UE8M0, exactly the format what DeepSeek mentioned. Let's quickly review FP8 formats: E4M3, 4 bits exponent, and 3-bit mantissa. UE8M0, all 8 bits used as exponent. In microscaling, we typically group 32 elements into one block. Originally, each element might be stored in 16-bit or 32-bit precision. But in MXFP4, for example, we use 32 4-bit numbers plus one 8-bit scaling factor. The key to microscaling is this scale factor. It maps a higher precision range into a low precision representation, then restores it with only minor accuracy loss. Let's have a real example. Suppose we have a block of 32 numbers in 32-bit format, including very small ones like 0.0012 and larger ones like negative 0.0048. Without a scale factor, small numbers like 0.0012 would run to 0 and large numbers could overflow. With microscaling, we find a scale factor that maps this 32-bit block into FP8's representable range. For example, 0.12, 0.015, 0.0012 converted to FP8 value 15, 2, and 0.15625. When reconstructed, 0.12 gonna reconstruct it to 0.117, 0.015 reconstructed to 0.0156, 0.0012 reconstruct to 0.00122. The error rate stays under 4%. Now compare the memory usage. Original block, 32 elements times 4 bytes per element, it's 128 bytes. For MXFP8, 32 elements times 1 byte equals 32 bytes plus 1 byte scale. It equals 33 bytes. That's about 3.9 times compression ratio with minimum precision loss. Now we should understand the data format and how the data is stored. But what does it mean for a large language model? Let's take a look. At the core, AI, especially large language models, is information processing and decision making. Whether the input is text or images, everything is vectorized into arrays, persisted through neural networks with many layers of matrix multiplications and nonlinearities, and then decoded into natural language outputs. In this process, about 90% of computation is matrix multiplications and additions. If we save 4 times space per number, the GPU achieves huge performance gains and bandwidth savings. Training large language model is extremely resource hungry. ChatGPT reportedly cost $38 million to train GPT-4. DeepSeek, the first one to use FP8 in LLM training, spent only $4.6 million, nearly 40% memory savings and 1.8 times speed up. And now DeepSeek 3.1 is the first to bring microscaling with UE8M0 into large-scale training. This makes us wonder, could the next generation even adopt FP4, the smallest format yet, and set new world records? To summarize, microscaling data format is a standard proposed by US companies. It can compress 32 bits or 16 bits data into 8 bits, 6 bits, or 4 bits with minimum accuracy loss. So microscaling will soon be the mainstream of the large language model training. IPSec 3.1 explicitly mentioned that they've been using UE8M0 and followed the standard for microscaling, but they didn't mention the precision they used is going to be FP8, FP6, or even FP4. So this leaves a huge suspense for their next release. Okay, that's it for today. If you like us, please follow, forward, or comments. Thank you and see you next time. Bye.